So today I'm just taking a step back on some work I did not too long ago with Vertex AI and specifically embeddings. So I got the chance to play around with Google Cloud's text-embedding-005 model in the Vertex AI model garden. And that kind of sent me down a rabbit hole into the world of semantic search.
Okay, nice. What type of stuff do you think you found out that you can share with us?
I've got a lot of goodies. To begin with, right? I built semantic search for this application called AIMDB, and it's a play off of IMDB. So IMDB stands for Internet Movie Database. And then AIMDB was really just a use of embeddings, Vertex AI, and some semantic search magic on top of that. But before we even dig into that app, I want to talk about semantic search at a slightly higher level and what it is, right? In the search world, if you think about the most primitive use of searching, it's traditionally done with regex. That's regular expressions. And if you're like typing something in, it's going to try to go through a list, let's say movies. It's going to go through a list of titles of movies to match your search. And while that has worked, I think as users, as humans, we've conformed to that norm and thought that it's the best format. But semantic search, in my opinion, should bring about us reconsidering that and saying, is there a more intuitive way to have that search experience if you're looking for something? That kind of brings us to like the benefits of semantic search. And there's three things really: improve relevance. And that's really just if you're looking for something, sometimes you may say something that is not what you think. And maybe you forget a movie title. Like in a case like that, if you're looking for movies on Netflix or your favorite video streaming app and you don't know the title of the movie, you just remember certain key things and you hope to get it. If it's only doing a simple search, you're going to get shortchanged. And then now you're going to have to go look somewhere else to eventually find your movie through other series of apps that hopefully get you in that direction. It also enhances the user experience. So that's going to happen because if you don't have to do all of that work, you're just going to be happier. And then another cool use, and I'm highlighting it because this is the real way like that we dug into it with this app that I built, which is better content discovery. So I think of a feature like, let's say you watch a movie, you love the movie, and you want a movie just like that movie next in your queue. If I want to find something similar, like how can I do that? And semantic search is a really good tool for that because you can understand the data way deeper than just a title. If you title match, I've seen so many things or books or movies that have similar titles. They're nothing alike, right? So that really takes us to how it works. And this is essentially like a diagram that illustrates the workings of a semantic search. And you have data, and then you need to embed that data. And the embeddings, in this case, I put here in parentheses, vector, and that's how I do it. So a vector is a series of numbers that's graphical. So if I were to pare down the dimensionality to 2 dimensions, it would look like a regular XY graph, right? With you have those 2 axes and you put a dot in a line. So what's neat about that is once you can graph something, it has its place. And then you can find things that are near it or in proximity to it. So you can find its neighbors. And that's like really the magic of the semantic search. And it does that through you generate those embeddings for the data, and then all your data is embedded. And then once it's embedded, you submit a query against that data. And the tool that kind of embeds all this for you would be an LLM. It's the workhorse. And I can show you like a code snippet actually that does that here. So this is the API of our application, and it has this embed text method. And in this embed text method, we're using Vertex AI and we're calling that text embedding 005 model. And then I'm specifying the dimensionality here. So as whereas before in my example, I said 2 dimensions, X and Y, this is 768. So it's a much bigger, more difficult to imagine graphical object. But what's nice about having all of these edges in our graph, in our like graphical representations, is that we can now represent data more holistically. Because if I have, instead of just 2 axes, if I have 768, that's, I don't know, 766 more ways I can convey the data. And then that dimensionality grows. So models have limits. In this case, the limit is 768 for this model, but OpenAI tends to have some that are about double that. And industry standard is moving towards a dimensionality of 1536, which is about double that. That would be like an example of how to do it. So that's essentially going to be when it's the first step where you embed the data. And then the second step is once you have all that embedded data, you're going to query against it, and then it's going to give you your results. And that kind of begs the question of RAG. So I'm going to just stop for a second, Jason, in case like you had any questions. I said a lot, and yeah. Do you?
Yeah, no, that was great. So you led me to what I had to ask was about RAG, because obviously the semantic search and whether
Perfect.
using the text embeddings or not. So what is the difference between semantic search, RAG? I think a lot of people are going to be familiar with RAG
Yeah.
in terms of retrieval augmented. And yeah, so just what's the difference?
Yeah, for sure. So I'm glad we landed on the same page. And I would look at it like this. Semantic search can be seen as a potential subset of RAG. So when you think of RAG, it's this broader process, this superset that encompasses several steps. You're going to have the retrieval and then the generation. And the real goal is just sanitizing your inputs and outputs, making sure that you do things in a robust, hallucination-free way. Semantic search can be thrown in the front of that. So like before you do a retrieval, you can have a semantic search mechanism that's going to take that user's query and then look for underlying meaning, intent, the layers beneath, and give you a better input that takes you to your next steps of retrieval and generation.
Okay, that makes sense.
And back on that better content discovery that we mentioned earlier, it's time to just check this app out. And this is AIMDB. IMDB stands for Internet Movie Database. And we just got clever with it. And we added an A to the front. And this is the front end. And this is running in Vite. And then here is the API that I showed the code for earlier. And that is Flask. And here are all the endpoints. So we can call an endpoint and get some information. So for example, I'll just do a really quick one. I'll do movies, counts, and then I'm going to do like title read, and it's going to give me back a number, and it'll tell me how many of movies with read in the title. And I got 219. So pretty large subset. And if you actually look at the data, there is approximately 23,000 records here. There's 23,000 movies. Unfortunately, it's not the latest and greatest. The data cuts off somewhere in the early 2020s, I believe. And it actually comes with MongoDB Atlas, if you include the sample data that comes with the cluster, the free tier. And there's an embedded movies collection, and I just created an embedded movies V2 collection. The only difference between these two is that embedded movies, which you can utilize vector search on, it has this embedding. And this embedding was done with OpenAI's, I believe Ada did the embedding. And you have a dimensionality of 1536. Now, if you use a different embedding model to do your embedding than the one you do the query against when you're doing your vector search, it's not going to line up and it may not work as you intend. So you want to ensure that your embeddings are done on the same model that you're also going to query against. And that's why I then embedded all of the same data, just with the Vertex AI text-embedding-005 model. And I got that 768 dimensionality we saw here in the code. So that's that embedded movies V2 collection. And then I'm just going to do a quick walkthrough of how this app works. So I'm going to start with a movie that I think will show really good results. I'm going to put Hercules. And then when I type in Hercules, it's going to give me back like all the results it finds. There we go. So it got 5. And then I see these 5 options here. So there's a Hercules from 1983, 97, and 2014. The 97 one lining up with like my memory, that's probably the Disney movie. And then this one, I think, yeah, it's the one with Dwayne "The Rock" Johnson. So this is like one of the more recent Hercules movies that came out. And this here is where we're going to utilize that semantic search, the similar movies feature. So when I click that, it's actually going to find everything like Hercules. And it does it based on this overview field. So this is the overview, and it's a bunch of text, not like a full-on plot summary, but enough that you have a gist of the movie more than just a title. And what's cool is that you'll see things in this similar movies category that a lot of them have the title Hercules, but we're really looking at the overview, which is shown here below, that leads to the similarity. And then we have our percentages on the top right, and it's sorted in descended order. So the most similar comes up first. So the Legend of Hercules comes up first, and then down with a pretty high similarity percentage is the Disney Hercules that I mentioned earlier. And then you've got some older ones. You even got Percy Jackson. So what's cool is that I look at all of these, and to me, they're relevant because I'm a huge fan of Greek mythology. And I know that all of this stuff is Greek mythology. It's battles with gods, demigods, you name it. So this is like an excellent result set for semantic search. But I don't want to stop it here. I want to show you that this is not perfect. And that allows you to consider expanding the way you do it. So I'm going to grab Hannibal. I'm also a horror movie fanatic. And I get 3 results here. And I'm going to click this, and this is the Hannibal movie. And if I click similar movies, I know the universe. So the universe has Hannibal Rising. It has Red Dragon, Silence of the Lambs, then Hannibal. That's the sequential order, like chronologically, just as far as how the events occur. So if you look at Hannibal, you get all of these, which is pretty cool, right? But remember, this semantic search is happening based on the overview. So this seems fine. But now I'm going to click into Silence of the Lambs, and I found this, I'm going to call it a bug. I found this a little bit earlier. Based on this overview, this was like the flagship movie of the series. It doesn't say anything about Hannibal in this overview. But when I run the similar movies on Silence of the Lambs, I actually get Alex Cross. And Alex Cross is about a serial killer. It is similar to Silence of the Lambs, but it is not more similar than the other Hannibal movies in the collection. And that is because it says nothing about Hannibal. So there's 2 things I would take away from this, which is, should my semantic search potentially include a title? Should it include characters? And those are all things you can do. You can expand the definition of your search. You can add more filters to it, and you can have a more robust search that is more than just like this plot overview. There, you can do something bigger, like a full plot. So it's a really interesting exercise, and you can see the limitations and the trade-offs of it. But yeah, that's a medium-ish dive into it, but I hope that at least showcased like the power of it. And
Totally. I'm curious, now that we've seen what the results are for Hercules in IMDB, maybe we can look at it in IMDB and see what results.
I'm going to bet on, of course, the app I built, but let's see. Okay, Clash of the Titans. There you go. So
It's not bad.
some of the similar results, and let me just put it up against each other because that's going to be fun to do. We got some similar results, but there's some that it missed. Okay. So Clash of the Titans, Wrath of the Titans. I do think it got those at the bottom.
Yeah. Okay.
These are the least similar in my search. Right. Whereas up there, those are the first 2. And yeah, if I keep going, it gets Immortals, it gets Legends. So it gets a few of them, and it seems to work pretty decently, but some of them are way off. So like Dracula, like that has nothing to do with Greek mythology. I don't know why that's there. San Andreas is even farther of a stretch, but it has Dwayne Johnson in it.
Yeah, it seems like a lot of things, if there's tags and just other data points to use to make the fidelity of the network, the mesh, not mesh, but I guess mesh is in my mind what we're looking at, of all these different pieces of data. And we're just looking at the overview in this case, and that's how it's drawing its conclusions. Gio, I think that was a really interesting look at how you can put something together pretty easy. It seems like using Vertex AI out of Google, along with you're just using a text embedding model, which is pretty simple. But yeah, thank you so much for showing us that and walking us through your demo.
Yeah, no problem. Thank you for having me, Jason.
Yeah, we'll see you later.